I'm here to talk about the very exciting topic of file management, particularly with our package called FS. And to make this boring topic a little bit more fun, I'm throwing in some cats, like my on-brand cat theme, and some like spooky file and folder names that we're going to clean up together. So, hopefully I can make this topic a little bit more fun. And if you want to follow along, there's a couple of R scripts that you can download from the GitHub repo, and I just posted those in the chat. Okay, so yeah, a little background. As Crystal introduced me, thank you for that. Data scientist at the State Department of Agriculture, and not in the sense of like the typical machine learning data science, but more like decision support tools, data management, that kind of stuff. And I have a little Etsy shop where I have sort of R and cat code themed stuff. And then I just have all my social links here if you ever want to connect. So first, I just kind of want to set the context for why file naming is important. I'm sure we're all familiar with the XKCD comics. This documents one in particular, I love because it kind of showcases the problems that I think a lot of us have when we want to keep like some scrap R code where we have like an untitled .r file, and then we just save it in these untitled documents because we just can't let ourselves delete it or get rid of it. So it just ends up in this like scrap untitled. So hopefully we don't have too many of those kinds of files, whether they're R scripts or documents that have names that are not helpful in the least for identifying what's inside of those files. And then the other scenario is that I think we're really familiar with is you finally finish a report and then you turn it in, then you get feedback, then you have to do some revisions, you get more comments, you do even more corrections, and the file name gets longer and longer and longer until you ultimately don't know when you're looking at your folder of files that all say final, which is your actual final document. So unfortunately, FS is not the answer for correcting these particular issues. You'll have to manually go through and open each of these files to see like what's in it and identify what the appropriate name would be. But I just sort of wanted to show the worst case scenario when it comes to really badly named things, to sort of set the stage for maybe just inconsistent but not bad names, and then using FS to sort of automate the cleanup of those kinds of file names. So if you want to follow along, there's two R scripts that are in this GitHub repo in the demo folder. So there's this generate spooky folder.r, and this one is going to create our messy folder that we're going to clean up together. And then I'm a total Cordo nerd, and there's this the new version of Cordo, the package. You can actually turn your QMD files into an R script. So I tried that out, and that is this link, if I can select it. That is this link here if you want to download just all the code chunks. Unfortunately, it doesn't keep like the slide headers, so it's kind of out of context, but you can use this R script if you want to just kind of run line by line and follow along that way. Or alternatively, from the slides, you can click the little clipboard button and like copy and paste into your own R project. Okay, so a couple ways to follow along. So first, I just kind of want to look at this folder that I generated using FS functions, but without actually going into the FS package, just kind of identify what is wrong with this folder. Like put in the chat, what do you see that grinds your gears? Or what do you see that maybe is not a best practice? Just kind of point out some things that are wrong with this folder.
But I'm having too much fun with the fun names, though. Distracting.
Yeah, see, this is me trying to make it a little bit more fun than just boring analysis one. Yeah, data folder has documents in it, files are misorganized, data files and scripts are mixed, inconsistent labeling, yeah, with the spaces, dashes, underscores. Scripts are not named in order to run. That's a really good one. The report folder has data. Yeah, so these are all um, really good observations. So there's a lot wrong with this folder. I think there's only like one or two files that are actually correctly named and in the right subfolders. So yeah, as you all have pointed out, there's inconsistent capitalization, inconsistent use of delimiters, the spaces, hyphens, and underscores. The file extensions don't match their subfolder. So again, there is like the CSV files in a reports folder. And it's difficult to know which is actually the final version because there were some that were like underscore final version 2 and things like that. So um, the woes of inconsistent, poorly named files. Why are these gonna make you have a headache later on? They're hard to find what you need when you need it. If you're constantly having to scroll through your folders and try to crunch through the noise and see like what file actually contains what you want or need. If you're using any of these files in scripts or your like analysis pipelines, then the names can break, especially with those special characters and spaces. That's this folder would be a nightmare for collaborators and for your future self. Like imagine going and looking for all the data files and then realizing, oh, they're in the reports file folder. So it's not very kind to yourself or any of your collaborators. And then you also could end up introducing errors from using outdated versions. Like if you're not sure which is actually the final most current data set you should be using because the names are confusing, it's likely to result in errors in your final reports and your analyses. And then it just wastes time and energy too. Like we all have way more important things to be doing than to be searching through and getting frustrated by looking for a certain file. So this is where the FS package comes in. So FS, file system operations. So they have a bunch of functions where you can create, rename, move, delete files and folders. And in this presentation, I'm going to use the terms folders and directories interchangeably. FS that works on multiple operating systems, and that's one of the like key benefits of using FS is if you're using it in your scripts, no matter if you're working on a Mac or a Windows, these paths will still work. And then it's inspired by the Rust programming language's FS module. And I don't really know about Rust, but I think I've heard it's supposed to be faster than R. So like this is supposed to be a really fast package for file operations. And then the FS package down has a lot of good resources. If you want more information, the reference will list all of the different functions. And so in this workshop, we have less than an hour and a half. So like we won't be able to touch on all of these. So I definitely encourage you to just go through and check out this documentation, and then they also have this article that compares the different FS functions with base R and then shell commands. Okay, so let's get into the basics. So there's four main categories of FS functions, and they all have really consistent and intuitive syntax. So there's path for manipulating and constructing paths, file underscore for files, dir for directories, and link for links. I don't really use links, but I figured it's important to just mention like link is if you want to create a symbolic link to a file or a directory. So like if you want to make like a shortcut, essentially. I don't really use them, but I just figured it was important in case some of you might be interested. And again, you can check out the package down function reference page to learn more about any of these categories of functions. So a brief comparison between the FS and base R is this can basically all be summarized to FS is intuitive and consistent, whereas base R, they sort of added these functions over time. And so they're not consistent with either their naming conventions or even like what they're returning. So FS, you can reliably anticipate that you can pass a character vector into any of these functions. And as the functions are vectorized, so you can like create multiple files at a time. Whereas base R, some of the functions you can do that, some of them you can't. Don't ask me which ones you can or can't. Go to the FS package down table in the article that I mentioned in the last slide if you want that comparison. Um, but the FS return values will pretty much always convey a path, and it'll be a special FS path class. So and that handles like the different operating system, like delimiters, whether it uses forward slashes or backward slashes. So we'll get more into that later on, but compared to base R, they are predictable, whereas base R, sometimes they have like just true or false, and then sometimes they have like these obscure error codes that are dependent on your operating system. FS has consistent verb function names. So like file exist, it has a pretty nice crossover to base R, which is file dot exist. But then like an example of like a weird naming one from base R is browse URL, which is the equivalent to file show if you wanted to like open up a file or an image or anything like that. And then FS will explicitly fail and throw an error if something doesn't work, like if you're trying to copy a file that already exists. Whereas base R, sometimes it'll generate a warning, and sometimes it'll just give you one of those obscure operating system error codes. So again, to summarize this table, FS is more consistent and it's more intuitive. And it works really nicely with the tidyverse like pipeline as well. When we near the end of the presentation, we'll talk about like querying files and folders, and you'll either get like these vectorized, or you'll get either the FS path as a return value or a tibble of like file information. So it's really, really nice with the tidyverse. Okay, so to get started, install the FS package and then call library FS. And we can just first see like what our folder structure looks like. So this directory tree, dir tree is one of my favorite functions because it nicely shows the scaffolding of your folder structure. So this folder that it's showing is the where my slides are hosted. So I also have this recurse argument, recurse equals to 2, and that's saying I want to show the 2 levels down from the parent folder. So you can see 1, 2, 1, 2 folders. Levels. And then if you wanted to have like all of your subfolders shown, then you could just do recurse equals true. So throughout a lot of the code, you're going to see me use this recurse argument. So I just wanted to point this out at the very beginning. So I mentioned this for like why use FS over the other base R functions is because it makes this like file path construction really straightforward because it handles the right separator for you. So for example, like Windows uses the backward slash versus Mac uses forward slashes. But if you construct a path with FS, so the FS path function, it's going to basically insert the right separator in between each of these subfolders. So in this example, I'm creating a path to a Halloween folder with a subfolder called images with a file called spooky cat. That's a PNG file. And if we call class on this path, then we can see that it's that special FS path class, which is a like special character. And then we can also run this function called path underscore abs for absolute path. And then we can see the entire absolute path. So my whole, like from the C drive all the way to the spooky cat PNG. And you can use FS to check for existence of a file. So you can do check if Spooky Cat PNG exists in the Halloween folder. So file exists, path, and we can see it says false because I actually don't have a folder in my RStudio project image that does exist in my folder. So I have an images folder, and then I have this image called mts.webp. So I can run file exists and it will return true. And I can also, I'll show you the file show real path. And it can actually open images in R for you, which is kind of cool. So first I need to call library fs and then make that path. And then file show real path. And then my cats popped up. So it's kind of cool if you ever want to programmatically open up a file, you can do that from R, which I didn't know until I started exploring the FS package. Okay, so we talked about the four like categories of functions as far as like directories, links, files, and paths. And then there's like four main verbs that they use as well, which are all very intuitively named: create, move, copy, and delete. Most of these work for files, directories, and links, with the exception of the move. So file move, you can move or rename a file, but it won't work with the directory or link. You'll actually have to like create a directory and then move it, um, move the files individually. So again, to recap that, there's the files, paths, links, and directories, and then we can create, move, copy, and delete. Okay, so then let's go through each of these functions and sort of see examples. So if we create a root directory in my demo folder, it's going to create this analysis called scary, and it's going to create this folder called scary analysis. And then if we do dir create root, then it's going to create demo scary analysis. And then we can create subdirectories within our root folder. So say like for our sort of R project, standard infrastructure, we'd want an R folder, a data folder with subfolders called raw and processed, output, reports, and images. So then again, we call the dir create function, and it's going to put all of these subdirectories into the. Okay. So I'll just show this really quick so you can see what I'm talking about. So if you were to try to create, um, first I actually have to create this root first. Okay, and then this guy. So that's gonna create in my demo folder, and then scary analysis, because that's my root, remember? So now I have R, and then data, and then raw, and then data process, then output, then reports, then images. And that's not what we want. So um, make sure if you're trying to create multiple folders or files in this case, or in yeah, folders or files, folders in this case, you combine it into a vector that you're passing it rather than just all of these individual elements, because then it's going to nest each of these within your root. Okay, so then say we want to create our four kind of R scripts that would work in our pipeline, like load data, wrangle data, model, and then visualization. And we want to put those in our R folder. So we can use that path function again to create the path. So it would go our root, which is, remember, demo scary analysis, and then our R subfolder. And then because these are all combined into one, these are all going to go into this R subfolder. Then we can use file create and then pass in this vector of scripts, and it will create our each of these R files in our R folder. So we can see our results after running all those lines of code, and we can see we have our scary analysis, our data folder with our two subfolders processed and raw. We have images, output, R, and then all four of our R files, and then our reports folder as well. Okay, moving on to copying. So we can also copy directories, which will also include all of the files within the directory that you want to copy. So it goes the path to the folder that you want to copy, and then the new path where you want it to copy to. So if we run our directory tree on our scary analysis folder and our other scary analysis folder, we can see they're the exact same. So they have the same directories, they have the same subdirectories, and they have the same R scripts. And FS is also really nice because it includes these built-in safety features. So, for example, if you were to try to copy a file that already exists, it's going to give you an error. So if I try to copy this load data script from my scary analysis folder to my other scary analysis folder, where remember it already exists, it's going to give this error saying that file already exists. You can get around this, like if you are intentionally trying to overwrite something, you can use the argument overwrite equals true, and then it will run just fine, and it will overwrite whatever was previously existing in that folder. You can also move folders and files. So in this scenario, we're going to create a new folder called source, and we're going to move our scripts into it. So we'll use the dir create function to create this new source folder. And then we can list all of our scripts in the R folder with the dir list function. Um, and then we were assigning it to this object called scripts. And then we can use the file move function to move all of those scripts into our new source folder. And the results look like this. So we have our R folder that's now empty because we've moved all of the R scripts into our source folder. So we now have an empty R folder, and all of our 4 R scripts are in source. And then we can also basically rename things with the file move. So there's no rename function in FS. Instead, you use the file move function to rename. So in this instance, we're in the other scary analysis folder now, and say we want to just change the name from R to source instead of having to create the new directory source and then moving things over. So in this case, we would just do file move, and we're doing the full folder. So just /R and then /source. And then we can see our results with the directory. And now we don't have that R folder anymore. We just have the source folder and our 4 scripts in it. So if your goal is to just rename a folder, you don't have to use that dir create like we did in the last example. You would just use file move in this one single step, and then it would basically create the new source folder, move everything over, and delete the R folder without you having to do like the multi lines of code. So back to the original scary analysis folder, if you wanted to then delete that R folder, you can then just use dir delete and it will delete it. So now we just have the source. We should have played a game or something, like how many times I say the word folder. My goodness. Okay, so this that's kind of just the preview to all the functions in FS. And now we're gonna move into like how we actually clean up a messy folder with these functions. So if you want to follow along, this is sort of the point where you'd want to source the spooky folder. Let me reset here. So demo generate spooky folder. And then this is going to create your spooky folder, which will then have like data, images, miscellaneous files, our reports, all like messy and disorganized, like we talked about. Um, maybe I'll post that in the chat again. This one.
Eric, do you have a question about copying or moving from
Yeah,
cloud?
I was wondering if you could move or copy files to the cloud drives that you're linked to.
To the cloud drives?
Yeah, like offsite.
Um, that's a good question. I I think so if you have access to them with RStudio, like and you can see them, I don't see why not. Like I use this on my share drive, or not, sorry, not my share drive, but like my shared network folders. But I haven't used it with like OneDrive or SharePoint yet. I wonder you might need to like use one of those like Microsoft packages to authorize like permissions. But I think if you can access those files within RStudio, you could, but I haven't tested like specifically like SharePoint or OneDrive yet.
Okay, thank you.
Yeah, good question. Okay, so this again is our spooky folder that's generated from that R script that we're gonna clean up now. But first, I'm curious because my program within my organization is kind of going through this like naming convention and like file cleanup process. And I like kebab case with like using underscores to sort of separate like the date from like the name of the file or other like groups of metadata. So I'm curious if you can put in the chat, like what do you use for your folders and files? And then I'm also wondering, is it standardized within just your projects, within your team, within your organization? How far does your naming conventions go? Snake case. Yep, snake case and kebab. Yeah, snake case, but not standardized. Yeah, I feel that. Camel and kebab. Snake case is dominating the chat right now. And I do know like it is kind of easier to remember because with R, like you have to use snake case for variables and function names and column names, or the hyphens can mess up your R code and stuff. So um, yeah, part of it is like it does seem easier to remember if just everything is snake case. So yeah, things to think about. Okay, so I do really like this graphic from Alice and Horace that kind of illustrates all the different naming conventions and cases you can use. So another graphic from Alice and Horace is the janitor package. Also curious in the chat if you have used the janitor package or not. I love it for cleaning column names. And then when I was starting to put this presentation together, I realized this would actually be really good for naming files and folders too, because you're able to just pass in your names, whether there's camel case, snake case, whatever. And if they have like special characters, janitor will go through and then clean it so that it's all the case of your choosing, and then it will replace like all of the spaces and special characters with underscores. So, we're going to use janitor to clean our names. So, we're going to use the dir list function to list out all of our files, and then use the make clean names function and turn everything to snake case. And you could use string R for cleaning, but I do really like janitor because it's really comprehensive. So like if you have kind of a mixture like we do in our case, where we have some camel case, some snake case, some kebab case, it's gonna already like have the regular expressions like within this function to change everything to snake case. So like my important file with camel case would be automatically turned into snake case without having to write the regular expression to say put an underscore before every capital word. It just makes everything a lot simpler. You can see the janitor make clean names documentation for more information and details on this, but I want to point out some of the arguments that probably would come in handy. Case, obviously, is where you're going to choose whether you want snake case, camel case, whatever. Replace is like, say you want to replace the percent sign with the word percent, or if you want to customize it to like PERC or whatever. Parsing option will decide like if you have like multiple capital letters in a row, how is it going to put an underscore after each capital? Abbreviation, so like my agency is WSDA, so I would use this to instead of having WSDA like W underscore S underscore D, I would this abbreviation argument would make it so that the WSDA is still kept together. And then the separator out is if you instead wanted kebab case instead of snake case, you could switch out the separator to be a hyphen instead of a underscore. So again, check out the make clean names documentation for more details, but janitor is very, very magical. So these are the results after using janitor make clean names. So we have our old file names on the left-hand side and our new file names on the right-hand side. And it did a pretty good job, except our directory separators, all of our slashes got turned into underscores because they are a special character. And then we lost our periods from our extensions. So we have everything lowercase and snake case, but we just need to figure out how to get these separators back and then the periods back before the file extension. So one step closer. So what do we need to do? There's a couple more FS functions that we can use to separate out the path into each individual part. So that way we can clean each part and then join them back together. So we're going to, again, list out all of our paths, and then we'll use the path split function to split the path into these different parts. And so here's just an example of what that looks like. It's a list, and then each element is each part of the path. So we're cleaning each individual part without the slashes for the separators. So then we can use per map, or you could use a for loop to then use make clean names from the janitor package and clean each part of our pathway, and then reconstruct with the function path underscore join. And then we'll have our clean paths. So let's see what that looks like. Okay, so we have our separators back, we have our slashes, but we didn't actually do anything about the extensions yet. So by cleaning each part individually, we were able to keep our separators, but now the next step is to fix the extensions. So this is where string R comes into play. Now we can use another FS function called pathExt to get the extensions. So we're going to create this new vector called ext. We're going to get all the extensions, remove the blanks that came from the directories with this subset function, and then remove all the duplicates, and then make everything lowercase just for consistency. Then we're going to make a regex to basically grab the underscore before the extension. So we're dynamically creating this pattern. So like we'd be able to grab the underscore before CSV, before docx, any of the extensions that we have in our folder. And it's out of scope for this talk to like explain the regular expressions, but I definitely use ChatGPT for regex. So highly recommend help with these because I can never remember all the different rules. So again, oh, I forgot to iterate this point of always, always, always checking your files before you actually rename anything, because if we had just gone ahead and renamed all of our files before we had checked and saw that the separators were gone and the periods were gone, that wouldn't have been good. And there's no undo button with FS. So you definitely want to be really careful and always check what you're doing before you actually do like move operations. So yeah, looking at our now clean paths, we see we have our separators, we have our extension period.r, period.csv, everything is lowercase, everything is snake case. The last thing is kind of optional, but for me, like I don't like how the R looks without it being capitalized. So I would like to recapitalize the R folder and the R extension. And we can use string R to do that. So again, we're just basically using string R to replace the lowercase r folder with capital R and lowercase dot R with capital dot R. And then this is just showing the all of our files in our folders. So now they're capitalized. Okay, so now we can almost complete the renaming. There's one more step, however. Our new folders don't exist yet. So this is sort of an FS gotcha where the file move and file copy functions, they don't automatically create your parent folders. So before we can move all of these folders to their clean names, we first have to make sure that the directories exist. So this warning or this error is telling you that we're trying to move this capital data folder into this lowercase data folder, but it doesn't exist because we haven't created these parent folders yet. So we first have to create them. So we can use this path dir function, and that's going to give you the directory, the path to all the directories. So it's only going to include the directories. It's not going to include the actual files. So this is listing out all of our parents, the parent folders. And then you can create the parent folders if they, sorry, I can hear my baby crying and it's a little distracting. My husband's walking her down the hallway. I don't know if, can you hear her?
No, not at
No? Good.
all.
Okay, so you can create the parent folders if they don't exist. So here we're using per map function so that it basically goes through each of these directories and then it checks if it doesn't exist, create it. And so then you can see like it's created all of these folders. And now once we filter out the folders from the current paths and the paths clean, then we can complete the renaming. So we've subset out anything that's not a directory. So we're just keeping the files. And then we're using file move to actually move all of those paths to our clean paths names. And optionally, you can delete the old spooky folder with the dir delete function. Okay, so then we can see our pretty clean folder. Everything is snake case and everything is nice and consistently named, but does anybody see what is still wrong? Yeah, the file types. So we still have our CSVs in our reports folder and some R scripts in our data folder. So we still need to do the organization part. So we've done the naming, we've done the cleaning of the names, and now it's time to organize. So we use the dir list function and the glob argument. So globs are like these wild cards. So we can assign all the paths that end in CSV or XLSX for data to this data, and then so on and so forth with your other like PNG for images, TXT for miscellaneous, R for R, and then like doc or QMDs for reports. And then you can customize this based on your own needs and what kind of files you have in your structures. This is from FS. The dir list is from FS. So moving files, once we have sort of the list of files that end in the right extension, then we can use the file move. So we're moving everything that we grabbed from this dir list in data into our data folder, and then moving all of our images into images, and so on and so forth. So then what that looks like, so here's our original spooky folder with everything misnamed and also disorganized. And then we have our cleaned folder. And now we have all of our CSVs and SLX files in our data folder, our PNGs in our images folder, our text in our miscellaneous, our R scripts in R, and our docs and QMD files and reports. And doesn't that like just make you feel so happy and satisfied? Like it's so clean. There's still, a little bit of manual work that you could do either at this step or at the like cleaning up. Like, do you want to keep both of these ghost data finals and as version 2? Do you want to do some like manual cleanup, delete one of them, or like rename it so that it doesn't say final? This untitled, like you'd still have to open this up and see if you want to keep it and probably rename it something a little bit more descriptive. So again, you can sort of choose to do this manual cleanup before or at this stage. But it's very nice. I mean, it took quite a few steps. It took 10 steps as how I've laid it out. But imagine doing this for like 20 different folders. And you'd probably have a lot more time on your hands to just run these few scripts and do some of those like manual checks and like a little bit of manual cleanup, as opposed to like going through and renaming every single folder and file by like right-clicking rename in your file explorer or whatever. So just to sort of recap the cleaning steps, first we used directory to sort of inspect the structure and see what we were working with, see the naming inconsistencies. Then we planned what new convention we wanted to use. In this case, we used snake case. We could have used some initial like manual edits, like opening up that untitled file and renaming it before we started coding, but we also could have done it at the end. It's up to you what your workflow looks like. And then we created new names with janitor and string R. And then again, very important to before you actually do like file move functions, you want to review what the new names are before actually running the file new or file move. So then we had to create new parent folders with directory create, and then filter out the folders from the files in the old and new path vectors. Then move the files with file move, and then review again with directory tree, and then any final manual edits. So this is a lot of steps, and like FS helps immensely, but there's one step further we could go to make this even a little bit more automated, and that is using functions. So instead of all 10 of these steps being their own process, we can sort of break it down into these functions. So this code is all what you've already seen in the different slides. So like a cleaning function where we're splitting the paths into the parts. We're cleaning each part to snake case. We're reconstructing the paths. Then we're fixing the extensions and replacing the underscores, capitalizing the R folder and R extensions, and then just making it an FS path again. So it's taking like, I don't know, 3 steps and turning it into one function. And this is also where you can take your individual, we got your individual, that's my train of thought. I got a little distracted by the chat. Sorry. Um, you can take your individual naming conventions and sort of customize and tweak these functions in order to work for your organization or your projects. So like in this case, we're using snake case, but if you prefer camel case or kebab case, then you can tweak that as needed. So then you can also do clean paths. So you can, what this looks like when you actually run the clean paths function is if we're starting fresh, we're sourcing this new, the generate spooky folder script, listing out all the paths, and then we're going to run the function clean paths, and then ta-da, we have all of our nicely clean names. But again, they're still not organized. So then we need our next function. Or actually, sorry, this is the clean paths is to give you a chance to review your clean names before you actually change them. Because remember, we always want to check our names before we actually use file move. So clean paths cleans it, and then you can do a manual check to make sure like, okay, these all look good to me. So then you can use this rename files function. And then that's going to do those steps of getting the parent folders, creating them if they don't exist, filtering out the folders from the files, and then actually renaming them. And then it also will print out your results. So I'm using a new FS function here called path common. And what that does is it is taking all of the paths that you've put into this function and then returning just one singular common path to all of those. So in our instance, it would be spooky folder. So this is what it looks like when you run rename files. It will print out the directory tree of our spooky folder, and now we can see all of our files are renamed as we like. And then the last step is to organize by the extension. So this again can be customized to your particular structure, whether you like data processed and data raw, or images like are if you have Python scripts, like you can customize this to whatever sorts of files you use often. And so you'll pass the input's going to be the folder you want to clean and organize, and then it's going to take each of the all of the files with these particular extensions and then move them into their appropriate folder. So when we run that, we can see we now have our beautiful folder that has our CSVs and our spreadsheets and our data, PNGs and images, and so on and so forth. So then we finally have our clean and organized, nicely named files and folders. So the full cleaning workflow with these three functions is take whatever folder you have, then get your paths to clean, then clean the paths and then review them. And then once you're happy with how they look, then you can rename the files and then organize them. And then you can do any manual cleanup as needed. Okay, so surprisingly, I'm ahead of time, even with all the Zoom bombing and whatnot. So there's time for this little bonus content. So FS is like even broader than just creating, moving, deleting, and copying. You can actually also sort of query your files and your folders, and it will give you a tibble. So I have so I'm doing this kind of in one step where I'm listing out all the paths in my demo folder and calling file info on it. And it's going to give a tibble of every single file and directory within this demo folder. And then you can see it has 18 different columns of information it gives you. A lot of these, I have no idea what they even mean. I know like FS you can use to like change permissions and stuff like that too, which I haven't used before, but it might come in handy for you. And what's really nice about getting it in this format is then you can actually like continue to work on it with like tidyverse functions like dplyr. So if I wanted to filter to show directories or R scripts, then I can filter it, and then I can also select the columns that I'm interested in. So if I wanted to see the path name, what type is it, what size is it, when was it created, and when was it last modified. So
You have a
you,
question in the chat.
yeah. How about any hidden files? Oh, good question. Hidden files, there's an argument for dir lists. I think it's called all equals false. So if you do dir lists and change all to true, hidden files will also be returned. Yeah, good question. Okay. Yeah, so you can get tons and tons of information, more than I know what to do with, but maybe you have a use case for it. And then you also can, like, if you're not a tidyverse person, you can also use base R and do the same thing, filter by directory or get just R scripts and then select just the specific columns that you're interested in. And then another little piece of bonus content is code snippets. Have any of you used code snippets in RStudio before? They're very, very fancy and I love them. Um, so no, so there's at least one person who hasn't heard of code snippets before. Okay, so they're super cool and I'm going to show you. Um, what you'll do is in an RStudio project under tools and then edit code snippets. These are all snippets where you can type in whatever it's called, like this one is called lib, and then you'll hit shift tab in an R script after typing lib and it'll insert this code. And then they have different snippets for different types of files. So the one that I use most is R or Markdown, which will work for Cordo and R Markdown as well. So if you wanted to sort of create like a basic scaffolding for an R project, you can copy and paste this snippet into, and I'll show again. So tools, edit code snippets, R, and then scroll down. And then I already have it set up. You have to like be careful with the tabs. So the snippet, you have to have at least one tab indent, and I guess when you paste it in, it is a little weird, but yeah, so you want to make it so that all of your code is at least one tab in, and then you hit save. And then if you're either in the console or if in your R script and you type in project and then you hit shift tab, it automatically inserts that code, which is really nice. So this is just one use case. So then if I were to run this line, then in my home directory, so this is FS Our Ladies SL, I now have images, output, R, data. So I have all of these folders now. So yeah, snippets are really, really cool. Like somebody said, they can be used for Shiny modules. There's a bunch like that are already built in. Another thing that I like to use it for is like creating a header for scripts so that I can include like a script name, purpose, date created, and then just sort of like preemptively attach packages that I use regularly. So a little aside for some bonus content. Um, oh, and one more off-topic snippet um, is also for actually I don't have it on this one. Oh, so snippet end. If you like to use like headers like analysis. And then you want to have like the dashes to make the like outline it show up in the outline, but you want it to go like all the way to the very end. If you're sort of type A like me and you want it to be like exactly 80 characters, you can use this snippet to like add it so that it has all the dashes to the end, which is very cool. Okay, and and then you put in what kind of delimiter you want, and then tab shift, and there it is. Okay, anyways, last little thing. And I think that's it actually. So then I just resources, the package down website. I did a blog post, guest blog post and video for For the Rest of Us on the same topic. So if you want it kind of in a different format and shorter, you can check out the post and video. Danielle has a really good and kind of funny blog post for FS. And if you need help with like naming files, Jadey Ryan has good slides for those. And then if you're like me and get stuck and have to look up regular expressions every single time, the string are regular expressions. And then I have my last links for the slides, source code, recordings, and other stuff. So there's lots of time for questions, or if you want to just like hang out and explore your own files with the FX functions, feel free to.
Yeah, I'm gonna go ahead and stop and then we can chat more. Stop the recording.